Let's graph another exponential function by plotting 5 points on the graph and also drawing the asymptote. The default horizontal asymptote is y equals 0, right? For any exponential function, y equals a times b raised to the x power. The default horizontal asymptote is y equals 0. But let's say you have a value being added, like plus k, like plus 5, plus 7, plus 2, then the horizontal asymptote will be whatever that vertical translation is. If it is minus k, well then the vertical translation, if you move it down, the horizontal asymptote will also go down that many. So when we are graphing this, I'm going to see if there is any number being added or subtracted. In other words, I'm trying to see if this graph has been moved up or down at all. Oh, guess what? I don't see any plus sign with the k. So this graph will have that default horizontal asymptote at y equals 0. So I will go ahead and get a dotted line, plotted or graphed on the x-axis, because that is what y equals 0 is. Okay, so this is let's go ahead and write this down. This is the horizontal asymptote at y equals 0, because there is no vertical translation. It did not move up or down, so it has that default horizontal asymptote at y equals 0. I need to plot some points. So to plot some points, I'm going to go ahead and just copy this down here and create XY table, okay? And for the XY values, remember that domain of an exponential function is always all real. I'll go ahead and write that down over here. Domain is from negative infinity to positive infinity, and range is different. But what domain lets us do is we can pick any x value if we want to. We can pick like negative 55 if we want to, but I just need 5 points. So what I may do is I may just pick like some positive numbers and some negative numbers. I tend to just do negative 2, negative 1, 0, 1, and 2. Those will probably do good. So I'll just do those numbers, okay? So if I plug in negative 2 into this function, by the way, y is, we have to multiply 2 times half raised to that x power. So if I plug in negative 2, that will be 2 times half raised to the negative second power. Okay, because we plug in x into the exponent. What's that going to be? That is 2 times positive 2. And that is just 4. Okay, because note, half raised to the negative second power is the same thing as 2 squared. Hey, hold on. I think I just made a mistake. Yeah. I should have put this number to be 4. Sorry about that. So 2 times 4 is 8. And you know, don't do what I just did. I was confused. So if you have a scientific calculator, you guys use it. Okay, you use it. I made a silly mistake because I don't know why. So if you plug in negative 2, in fact, let me show you. I have a scientific calculator open because I was recording those compound interest problems here. All right, if you do 2 times 1/2 raised to the negative second power, is going to give you 8. So if you have a scientific calculator, use it. All right, another one. 2 times half raised to the negative first power. That is the same thing as 2 times 2, which is 4. But hey, I have this tool open right here. How about I use it? Yes, if I plug in negative 1, that comes out to be 4. What if I plug in 0? That will be 2 times half raised to the 0th power. And remember, anything raised to the 0 power is just 1. So 2 times 1 will give me 2. And if I want to check it, yes, we got it. And the next one is going to be a little bit tricky. well, not that bad. 2 times half raised to the first power. Anything raised to the half power is just, half raised to the first power is just itself, isn't it? So 2 times half is 1. And if you want to check it, you can check it on the scientific calculator. And the very last one, I think the last one is going to be a fraction. My computer is slowing down very much. 2 times half raised to the second power. Half times half is quarter. And if I multiply 2 times a quarter, that is going to be half. And just to double check, I'll plug it into my scientific calculator. It got me a decimal. I can click on this fraction button and it's going to give me a 1/2 back. And decimal is actually okay because I'm going to go ahead and plot these later. But I now have 5 points to plot. All right, let me see. I will now go ahead and plot these 5 points. All right, hold on 1 second. Make this a little bit smaller. Let's plot -2, 8, -1, 4, 0, 2, 1, 1, and 2/2. And let's see what it looks like, okay? So first of all, -2, 8. 2 to the left, up 8. Here's my first point. Next point, -1, 4. 1 to the left, up 4. Here's my second point. Third point is at 0, 2. 0, 2. Next point is at 1, 1. 1, 1. And the very last one is at 2 to the right, half up. So right here. And I can see that the graph will extend, or the graph will increase infinitely to the left. The left end behavior is just shooting up, it's going up, okay? But the right end behavior is going to approach that horizontal asymptote of y equals 0, but it will never touch 0 or cross that line to go down to the negative. Because why? Think about this. Come here and look at the y values for me. Look at these with me. Half of 8 is 4. Half of 4 is 2. Half of 2 is 1. Half of 1 is half. You see what's going on? We're taking the half of the y value. The base is half. Anyway, because base was half. If you keep on taking half of something, you have $1 million and you keep on taking half and half and half and half. Are you ever going to have a negative amount of money? Never, right? Are you ever going to have a $0? Well, it could be $0, but like, you're going to have like a fraction of a penny, right? So it will never really be 0 or negative. It's just going to approach 0. So that's why this horizontal asymptote of y equals 0 is on this graph. And let's talk about the range. Range. The lowest point that is going to try to approach is 0. And the highest value is just going to keep on going up to the right, to the left. So the range is going to be from 0 to positive infinity. So we graphed two exponential functions. The first one was going up from left to right, so we call that exponential growth. The second one that we just graphed is actually decreasing from left to right. So you do want to say this is an exponential decay function. Okay? Because it was going down from left to right. So that's enough for this graphing problem. We got the domain and range. I will come back and talk about translating the graph of rational functions in the next video.